Welcome. In this video, I'm gonna teach you how to use the shell method of solids of revolution to find the value of a torus as follows. We're gonna find the value of a torus. So let's say this is your x-axis, this is your y-axis. Let's say this is 1, this is -1, this is -1, this is 1. So let's say here is 2, and this is the line. This is going to be the axis of revolution. So this is x equals 2, and then the circle, function of the circle, of the outside of the circle, is going to be represented by the function x squared plus y squared equals 1. So our task is to use the shell method. Okay. So what we're gonna do is that we're going to create a rectangle, and that rectangle has a weight of delta x. And then from here to here, that's gonna be your h of x, which is your p of x. P of x, which is gonna be your average radius from the center of your rectangle to the axis of revolution. Okay, so the first step is to solve this circle function. So this is a circle. First step is to solve this for y. That means that we have y is equal to square root of 1 minus x squared. Okay. And now we know that the volume using the shell method is going to be volume is equal to 2 pi the integral from a to b of p of x times p of x times the, which is the times this one here, so I'm gonna call it h of x dx. Okay, so the way we do it, remember that when we solve for y equals 1 minus x squared, we're only solving for half of the circle, the upper part. So that means that our value has to be multiplied by 2 to get the whole thing. So that would be 4 pi, and then we go from -1 to 1, off from here to the center, that's going to be 2 minus x times your function, which is 1 minus x squared dx. Okay, so now, because here it's hard to do like this, what we're gonna do is that we're going to split this thing as follows. So we're gonna do 4 pi -1 to 1, 2 times 1 minus x squared. Then we're gonna do dx. We're gonna do minus 4 pi, and then -1 to 1 x, and then 1 minus x squared dx. So the next step is to solve each. Notice that here we can pull out a 2, so that will be a pi -1 to 1 of 1 minus x squared dx. And here we can use u substitution. That will be u equal to 1 minus x squared and u prime equal to minus 2x. So then this becomes minus 4 pi -1 to 1 of u 1/2 du. Because we have an x and we have a -2, so that's what that whole thing becomes du. So basically du, this will become -2. So this becomes positive 2, because we took out a -2. Actually, one second, -2. Yeah, so -2. And then du, that's du, which is u prime. -2 pi, yes, -2 pi. Becomes positive -2 x. Okay. By symmetry, this becomes 0. So this becomes 0. And then all we're left with the left side here. And notice this is the area of a semicircle, the upper part. So we don't need to solve this integral, too complicated. So what we're gonna do is we're gonna do a pi times, because the inside here, this is the area of a semicircle, that's gonna be multiplied a pi times pi over 2, and then the radius is 1 square. So then this becomes a over 2 pi squared. So this is 0 here, okay, so that's equal to 4 pi squared. Which is the volume that we were looking for. So the volume is going to equal to 4 pi squared for this torus when it's centered about the line x equals 2. Thank you very much. Don't forget to subscribe, please.